Today's great code question. Um, so what is the problem? Problem is path with maximum code, but we are given a matrix of integer type, basically two-dimensional array, but we supposed to output maximum sum of integers in same path. Basically, we have to find maximum sum path, and a condition is there: the path should not contain zero. That's the thing. What we can do, we can move up in a like basically if we are I comma jth index, we can move to up, that is I minus 1 comma jth index. We can move down, that is I plus 1 comma jth index. We can move left, that is I comma j minus 1th index. We can move right, that is I comma j plus 1th index. These four changes we can do, then motion movement we can do from current element. So we use simple DFS algorithm and explore the map, and for each non-zero element in the matrix, and store the maximum sum, and and among that path we calculate sum, and then return the maximum sum. That's the basic approach. Very simple. Let's look at the pseudocode. What we do, for each row, for each column, basically we are iterating over each element of the matrix. If each any element is greater than zero, basically it is non-zero, negative energy, it is greater than zero, then we choose it as the start point and apply the DFS function. What DFS function return? DFS function return the sum of that path, sum of integers on that path, and we update maximum sum if the current sum is greater than the previous path. जितने भी पाथ है अभी तक उन सब में से किसी से भी बड़ा, उन सब में से जो मैक्सिमम था उसके मैक्सिमम से भी बड़ा है, तो फिर मतलब अपडेट ओवरराइट कर देंगे मैक्सिमम को, वरना नहीं करेंगे, to find maximum sum over different positions. So what DFS function will do, we will write DFS function in recursive manner with the base condition, that is I comma j should be in range. If it is not in range, then we return 0. Not in range means I is less than 0, j is less than 0, I is greater than number of row m minus 1, j is greater than n minus 1, or current element is not equal to 0. These are the conditions in which we return 0. After that, we move down, we move up, we move left, we move right. That's the thing, and return temporary plus maximum of that person. That is our path with maximum gold question. So let's implement this in code, in VS Code. Let's go. So what we first is which what number of rows grid for dot size, then we number of columns, grid array of 0 dot size, then number of rows, number of columns, grid array, and then we iterate over each element in the matrix for the use a nested loop for and I equal to 0 plus 10 and 7 plus plus for and j equal to 0 less than and 7 j plus plus. If grid array of I, array of j is equal to 0, is equal to 0, then not then then sum is equals to dfs of I comma j. We will pass I or and j in the dfs function. Why we are not passing grid? We make dfs function in that function. We are using lambda function library of C++. This makes our work easy. And then we update maximum sum. If maximum sum is, then we update maximum sum. This is very easy. and then we have to return maximum sum. This is our question. Now we have to implement DFS. This is the main part of our code. DFS, how we implement DFS? We use lambda function functionality, but it return is an integer, but it takes is integer for integer. Okay, but its name is DFS. What does address pass कर रहे हैं? By address हम पास में reference कर रहे हैं ing को. And then what it takes is integer I j, basically name of the parameters I or j, and then we do what is an integer, what it returns as an integer. This is our function template. Okay, let's implement it. And this may be incorrect. We check it in last of our video. This is maybe syntax error. I equal to sorry क्या करना है? In the areas what we have to do, firstly we check I and j should be in range. I should not be less than, if it I is less than 0 or j is less than 0 or I is greater than greater than n minus 1 number of rows, j is greater than number of column minus 1 or grade array of I, array of j is equal to 0. If any of these conditions satisfied, then we return 0. We do not accept that path. If these conditions are not satisfied, then we go further. We move up, down, left, right. But before doing this, we have to consider that our path do not contain any cycle, any loop. For avoiding that cycling or looping, we have to make current element uh, zero. Zero. But we have to cut back the make that element right. So for this, because this may produces incorrect value because in some other path that element may come. For this, we have to make a we have to store that value in temporary variable I j, and that's the thing. Okay, the temporary में store हो गया, greater of I j 0 है, and now we have to move up by dfs. अब कैसे मूव करेंगे? I minus 1 कोमा j. डाउन कैसे मूव करेंगे? डाउन कैसे मूव करेंगे? I plus 1 कोमा j. लेफ्ट कैसे मूव करेंगे? I कोमा j minus 1. राइट कैसे मूव करेंगे? I comma j plus 1. These are the following. Then we have to return the return current element sum. That is, we have to correct our current element. Current array of I, array of j is equal to temporary plus main maximum of u comma d comma left comma right. Yes, that's that. This should work if there is no any syntax error in this line, seventh line. Let's check our get maximum code function. We are treating over each element in the array. If it is non-zero, then we are executing DFS function. DFS function is doing a base condition checking I or j should be in range and element should be non-zero. Then we are storing that current element and temporary and making it 0 for avoiding looping. And then I should commit this part. I should write here. So writing avoiding loop. And then we have actual movements up, down, left, right. Get array of I, which is first temporary and return temporary plus maximum of up, down, left, right. Let's see. It should if there is no any syntax error in this line. Oh, sample. Why have not declared maximum? This is a select state. Maximum sum equal to 0. Roman say I is less than 0, j is less than 0, I is greater than n minus 1, j is greater than n minus 1. Greater of I, j is equal to 0, return 0. Integer temporary greater of I, return 0 plus maximum of isn't 0. It is return 0. Minimum conditions. Mm, maximum is equals to maximum of some maximum. Why this is behaving? Oh, I have to check it is not equal to 0. It's right. Now if I submit it, that works. So this is about final conclusion. Let's see its time complexity and space complexity. Time and space complexity. It is taking time off because the DFS function is taking exponential time 4 की power. In worst case, if there is not even a single zero in the matrix, it is taking 4 की power m cross n time, and we are executing this for each element, then m cross n times of 4 की power m cross n. This is overall. This is overall the exponential time complexity. Space complexity is because of m plus n, because this recursive function takes stacking. If in first case all elements are included in the same path, then m plus n, m cross n, because of m cross n, all the elements are included in the same path, because of m cross. So this is our let's write it here. Time complexity from time because of m cross n cross 4 की power m cross for space is bigger of m cross this. Hmm. So it's done. Conclusion of this question is we learned how DFS how we can apply DFS to search thing in a matrix in a 2D array. And by this same concept, you can also use I also implement word search problem and word search problem in a tool matrix. That's the thing. So goodbye, meet you tomorrow.